study how mathematical thinking develops, the research team began by asking, how might children solve problems that use mathematical ideas before the procedures to solve them were formally introduced in school?
Pepper, you got 4. And then when you had the sausage, you got 3. And when you had the mushrooms, you got 2. And when you had the pepperoni, you had 1.
Here's this group of students, just, kids going to school, doing what was expected, and now we're challenging them with problems, and they were taking them, solving them in ways that were very impressive to us.
If I stagger it by 1, the surface area changes.
Yeah, because it opens up more dimensions.
We pulled back and gave them more, and they responded to more. And we pulled back and gave them more, and they responded to more.
Okay, and you've come up with a general rule to find the surface area of all the rods if I stagger it by 1.
Yes.
Okay, I can't wait to hear this formula.
Yeah.
Because volume.
I hope that we can show that under certain conditions, and these conditions were not in place all of the time. Remember, we went in 6 times a year in the first few grades, and then maybe 4 times a year in middle grades, and so on and so forth. That kind of an intervention seemed to be very, very important for this group of students. And we did not change all of the curriculum. We didn't throw out textbooks. We didn't say to teachers, don't do what you do. What we tried to do is bring into the curriculum thoughtfulness and the notion it's so very important to understand fundamental ideas. The building blocks really have to begin very early.
Towers. Students were asked to select from stacking cubes of 2 colors and assemble towers of a given height.
We have 16.
See these 2? Are we going to call these the same or different? Matthew? Jeff? Same. The same. We're going to call these the same. Even though I'm holding different blocks, I really am holding different blocks. For our purposes, we're going to call these the same. And we didn't say that. Jeff, what do you think is going to be another condition about our towers?
You can't turn it around.
You can't turn it around. It has like a chimney on top. Do you see that? Okay. How many do you think you can build under those conditions? Do we have any good estimates of how many we can build? Dana, what do you think?
13.
Dana thinks 13. Okay, do we have any other guesses? Jeff?
25.
Jeff thinks 25. Anybody think something else? Steve?
10.
Steve thinks 10. What do you think, Jamie?
10.
Jamie thinks 10.
15.
15?
12.
12?
26.
26? Sebastian?
12.
Well, we're not agreeing on this. Jennifer?
15.
Matthew? Well, I think what you're going to have to do is work on it and see how many, but remember, you have to be sure that you have no duplicates, you can't have 2 the same, and you have to be able to convince us that you have found all possibilities, that there are no more or no less. You got the problem? Have fun.